Hi everyone! Today we are going to be looking at the essential question of how do we dilate an image? Over the last few lessons we have been looking at transformations and changing images. We talked about rigid motion, meaning that those images that we have been transforming preserve the length and the angle measure. Yesterday, or in our last lesson, we talked about congruent figures having the same shape and the same size. Today, we're going to talk about figures that are dilated. Dilated means that they can either become bigger, enlarged, or smaller, reduced. And so with today's lesson, we are going to learn how to enlarge dilations. Okay. So, first of all, what is a dilation? Well, a dilation is a fancy word for a transformation. So again, we're changing the shape. Transformation. A transformation in which the figure becomes larger or smaller. Well, let's use the in which a figure is made larger or smaller. And they tell us that it is in respect or with respect to a point called a center of dilation. And we will talk about what that looks like. All right. So dilation is just a fancy word for taking a shape or a figure and making it larger or smaller. But this respect to a center of dilation, that means that there's going to be a center point that we use in order to grow or shrink that image. So let's go like this. If I had something that looked like this and this point right here would be the center of dilation. It's the starting point for how the shape is going to change. So if I had a shape that looked like that, and then it grew, we would use the center of dilation here to show what's happening. Okay. In dilation, as it dilates, it gets bigger, right? So this center of dilation is causing this to get smaller, but you would also, or larger, but you would also have one that would cause it to get smaller. And today we're just going to be talking about dilations that are enlargements. All right. You can see here through the center of dilation that the points match up. So they're congruent in their angles and also congruent in their angles and their, what does it say in a dilation? Yeah, their original figure are congruent. So these are congruent. It's just that you've used the dilation to either enlarge them or make them smaller. So congruent angles. All right, now let's apply this so that this makes a little bit more sense to you. So we're going to take a shape and we are going to dilate this shape. And when we dilate it today, we're going to be looking at enlarging the figure. Okay, and when we enlarge something, we're going to use something called a scale factor. A scale factor tells us how much we're either going to grow something or how much we're going to shrink something. Okay, so when we're looking at scale factors, it tells us how much to either grow it or shrink it. So here is our first example, example A. And example A says that we have a triangle that has vertices A, which is 1, 3, B, which is 2, 3, and C, angle C, which is 2, 1. And they want us to enlarge this with a scale factor of 3. So scale factor of 3. So what this means is that we're going to take our original points and we're going to multiply them by 3 to get an image that is bigger. It will preserve the angle measures by doing it that way, so that our images are still congruent. So let's go ahead and first graph our image that we have, and then we will go from there. So the first one that we're looking at is 1, 3. So we're going to go over here to 1 and then 1, 2, 3. And then 2, 3, so over to 2 and then 1, 2, no. Well, I guess so. Over to 2 to 3. And then the last one is 2, 1. So over 2, up 1. So the triangle that we have looks like this. Okay. Now they want us to enlarge this or dilate it with a scale factor of 3. So that means that we are going to take this 3 and we're going to multiply it to the x value and multiply it to the y value. And that will give us new points. So our new x value is going to be 3, and our new y value will be 9. So our next point will be at 3, 9. So making that change of multiplication gives us the image of A, and it is 3, 9. So we're going to go over to 3, 1, 2, 3, and then up to 9. I really hope I have 9 spots here. 1, 2, 3, 4, 5, 6, 7, 8. Oh, I'm off the charts a little bit. Okay, I'll put it right there. 9. And then the next one, we're going to go, here's my x value, 3 times 2, which gives me a new x value of 6. And 3 times 3 again, which gives me a 9. So that's our new B. So we're again going to go over to 6, 9. So 1, 2, 3, 4, 5, 6, and then up here to 9. I'm just going to put it right there. And then 2, 1. So 3 times 2 and 3 times 1. My new x value is 6. My new y value is 3. So I've enlarged this by using multiplication with a scale factor of 3. So 6, 3. So I'm going to go over 1, 2, 3, 4, 5, 6. And then up to 3, 1, 2, and 3. So when I connect these points, you will see that I have a new triangle that is an enlargement of this purple triangle. The center of dilation comes from the origin. Okay, so if I were to draw lines here and connect these dots from the center, you could see the center of dilation is happening from the origin. All of the angles measure up, and everything gets bigger or enlarges from the scale factor, that we used of 3. Okay, so when you're looking at this figure, you can see, that looks really cool. You can see that the center point here, the origin, is where all of the dilating is happening from. Okay, so in this case, we used multiplication, x by 3 and y by 3 to get our new points. Okay, we're going to do another example, and in our next example, again, we're still going to dilate the figure. We're going to make it, still making it bigger. So there we go, but let's go ahead and check out what our new scale factor is. So we want to use a scale factor of 2 this time. So we're going to use a scale factor of 2, which means that when we're dilating, because it's a whole number 2, we are going to be enlarging the figure and making it bigger by multiplying by 2. So let's go ahead and get this all settled out here. We're going to take our sticky note. You already have your lines drawn, but I do not. So I'm going to draw mine. Okay. And we're going to start with a figure that has, it's another triangle. Okay, so we're looking at another triangle, and this triangle has vertices that are D, and D is 1, 4. E is 1, 1, and F is 3, 1. So that's our original. We're using a scale factor. So our scale factor, it's a dilation with scale factor of 2. Sorry, the trash man is right outside my window right now. All right, so we have 1, 4. So we're going to go over to 1 and up to 4. Over 1, up 1, 2, 3, and 4. That is point D. E is 1, 1. So I'm going to go over to 1, up to 1, and that one is E. And then 3, 1. So over 1, 2, 3, up 1, and that is F. So here is our triangle. You can see that it is a right triangle. The points line up and come straight from the origin. We use the origin. Now we have to dilate this by a scale factor of 2. So we're going to take each of these points and we're going to multiply them by 2. So 1 times 2 is going to give me a new x value of 2. And 4 times 2 is going to give me a scale factor of 8. Or I mean a point of 8. So I have 2, 8 is my new D point. This one I'm going to multiply by 2 because it tells me to. 1 times 2, that is 2. And 1 times 2, that is also 2. So E1, our reflection of E, or not reflection, our image of E, is going to be at 2, 2. And then we're going to transform this one, 3 times 2, and 1 times 2, and that gives us 6, 2. All right, so let's go ahead and graph our new points. So 2, 8, I'm going to go over 1, 2, and then up to 8. 1, 2, 3, 4, 5, 6, 7. Why do I keep going off the page? 8. That one is D1. And then my image of E is at 2, 2, so over 2, up 2. Notice how these points are already starting to line up. If I could draw my lines here, the dilation is happening. F1 is at 6, 2, 1, 2, 3, 4, 5, 6, up 2. And now I'm ready to connect these dots. What's this? E, F, and then we'll see what we get. Do, do, do. All right, there's E to F. E to F is connected. Now we need F to D. And boom. This figure is the same as the pink figure. So the dilation has occurred. It's just taken a small triangle and exploded it to become a bigger triangle. All right, it is your turn now to do a dilation. Try it. So let's give you your try it down here. On your try it, you are going to dilate a figure, and your figure has points of 1, 3, and 2, 3, and last but not least, 2, 1. And I would like for you to dilate this by a factor of 2. So dilate, oops, I spelled that wrong. Dilation of 2. Okay, so your scale factor equals 2. Go ahead and hit pause right now so you don't hear me solving this. And then when you're ready, come on back and hit play to check your work. All right, number 1, let's go ahead and graph our first triangle so we can see what image we're looking at. Hopefully I have more space here. I cut this a little bit differently. Otherwise I'll still be off the charts. All right, so my first triangle, let's keep it green. 1, 3 over 1, 1, 2, 3. There's A. 2, 3 over 2 up to 3. Oh, it's the same triangle as 2, 1 in our first example. Okay, but we're dilating it by 2 this time. So we're dilating it by 2, which means that we're multiplying by 2. That is the change. So 1 times 2 is an x value of 2. 3 times 2 is a y value of 6. So I get 2, 6. The next one, 2 times 2, and that gives me 4. And 2 times 3, that one gives me 6. Look, so far we know we're on the right track because these both were 3. They're both 6. All right, now we're going to do 2 times 2. Our new value is 4. And 2 times 1, and that gives me 2. All right, so let's go ahead and graph these images. All right, so 2, 6. I'm going over 2, up 1, 2, 3, 4, 5, 6. And 4, 6 over 1, 2, 3, 4, up 6. So far, so good. I'm looking the same. I'm looking congruent. 4, 2 over 1, 2, 3, 4, up 1, 2. I'm going to connect my dots. And I have a congruent triangle. All my center points line up. Everything matches. It's just enlarged. All right, how are you feeling about your essential question today? How do we enlarge figures using dilation? Go ahead and answer that question, and then put your level of understanding out to the side. How are you feeling about this? When you're finished, you can come on back to the Google Meet and ask for help, or you can go on and do your practice work. As always, I appreciate all of your hard work and effort, and make it a great day.